Hey guys, how's it going? I'm back with another video, which is I don't want to say a very different video, but it is somewhat of an interesting video that I haven't seen many people doing. We all know how to code and how to program and make stuff and tinker with stuff, but it is often not taught how to actually properly do the stuff that we do, especially in the tech community. Over the years, I have picked up a few habits, though not many years, but they are very precious to me. And I feel like the workflow that I have learned from that and adopted is pretty unique. And I feel like this is a pretty stable way of doing stuff and to ensure that the results are positive and on time. So I'd like to walk you through what kind of planning I do before I do a project, and especially when it comes to clients and how to deal with them. The first project that I did, a couple of years ago, was very hectic, and I didn't actually know how to actually plan the project and talk to the client and ask them questions and what details mattered and what not, and how to manage the time. And so I'd like to be walking through all of that and basically lets you be a part of the journey of doing a project for an actual client. So this is the project which is called this is for a pneumatic press. So it is for a factory, and what they're doing is that they have a drill, not a drill, they have a press which is automated by a pneumatic valve that is controlled by a relay, and they have a screen and an interface and a couple of more details that I'd like to go through now. So first, when a client approaches me for a project, I first ask them to share a PDF with me, and that PDF is actually very important. First, it lets you understand what kind of a mindset that the client has, what kind of expectations that they have, and how far can you go with them. If you do not have that kind of a PDF, it's very hard to gauge where they're coming from. So I'd like to show you the PDF that I first demanded from them. This is the PDF that they shared with me. As you can see, it's January 15th. It's a pretty recent project. And the first thing I asked them what the project is about and how long do they have, and whether they are chill about the deadline, or is it like a company and they have lives dependent on it. So I try to gauge the complexity and the stakes for the project. And this is very important to understand whether this will go easily with your other projects that you have going on or not. If it's something that you can't do, you should probably stay away from it and not leave it to chance, though I am not the right person to be saying that. But here's the PDF that they have shared, and as you see, this is a pretty rare client that has gone through the trouble of creating such a detailed sketch. They have provided me with the model of how the project would look like, what kind of a display they're using. As you can see, they have mentioned that they will have 3 buttons, up, down, and mode button. And the main problem that they had, as I gauged from their conversation, was that they were beginner in the programming phase, and but they understood the circuitry and how to wire things up. But they were struggling with the menu system. As you know, on microcontrollers, especially the 8-bit microcontrollers, the menu system is a hell to deal with, to say the least. This is why most of the TFT displays and everything, they have displays and menus built into them. And unluckily for me, I have actually been programming menu systems since the start, and that was a very rough experience that I did. I would not recommend it to anybody to start with the menu systems, but it does kind of teach you the state machines and what kind of interesting things that you have to go through to be able to achieve that level of control in your menu, and the kind of hard work that goes into the menu system. Anyway, they have mentioned a schematic, kind of. They said that there's a controller, limit switch, pneumatic solenoid valve, and a press that they have very nicely sketched. And there are 2 switches which will control the pneumatic valve, and these are for the safety of the individual as well. When they have the 2 hands on the switches, this will ensure that their hands do not get sucked into the machine, and the limit switch is to measure when the press hits the ceiling, so that no further force is applied into it, if at all, or to start the timer. Going coming down, they have again very nicely exploded the schematic right in our face, and this helps a lot. They have clearly mentioned that there's a voltage converter that they're using, and what kind of a relay, and what kind of an LCD and stuff. And so here's the logic that they have mentioned. If this logic is not present in the client's initial demands, I will ask them to verbally or write it down what kind of a logic that they need. If they are unable to do that, then I will make something up as I am understanding that, and then I will write that up for the client, and then we'll discuss whether I am right on the path or not, or whether I have something missing. And so, but this made everything easier for me. But then again, I discussed with the client again if this is correct and what I understood from it. But this is the most important part. The other thing that is most important in such projects, whether you're doing at such a small level, this is would probably be called a hobbyist level, not actually a job. But this is probably the most limited project that I could show you, which would fit into a YouTube video. The most important things that you would like to ask the client are the deliverables, the deadline. For example, they asked me to share a schematic to guide them how to wire it up, and until and unless everything checked out, they were very skeptical of the progress. So I gauged that from their conversation, and then I made a few decisions which I'm going to tell you later. And they have again very nicely made it up into a breadboard circuit, which again told me that they have tried it to make it, but then they're definitely facing some issues with the menu system. And this was probably the most focused part that I wanted to be, or I wanted my focus to be the maximum in this phase. Coming back up in there, I decided to jump right in, and through this video I'd like to also share with you a very interesting project going on the internet. It's called walkwe.com. It's basically an online simulator for ESP, STM, Arduino. Basically uses Arduino framework, so it's pretty easy, saves you the time of actually wiring up the circuit, and gives you a very nice simulated space where you can put all your relays and buttons and microcontrollers and whatnot. And it works, I would say, probably very nicely. I was not expecting it to work this well, but the people behind this have done amazing work. I'd like to link to their channel if I can, but do visit them. And this is, most of all, it's free, and it can be integrated into the VS Code environment, where you can program your native ESP32 programs with the ESP IDF, and STM32 with their Cube HAL and whatever. So this is a very nice initiative from them, and it's pretty old, but I haven't seen a lot of people using this. So I said, why not? I should probably try this and see what kind of things I'm doing. So first thing that I'd like to do is always start with the schematic, and here I have made the schematic here. I'd like to show you how I started with the schematic. So what I do is, even so that this is overkill, but I still always like to make my schematics in here, which are pretty neat, and shows me what I'm trying to do and what kind of problems I will be facing hardware wise, because that is the bottleneck when it comes to programming. I have made a symbol for them which can be easily read, and marked the lines, and put the proper the names of the components, which makes it very easy to debug later on when you're looking at it, for like not even debug, just like reading it after a few years. So that's pretty good what it's trying to do. And here's a relay, and and here I have written my company's name. This is always nice, gives it a professional touch, and the title of the schematic and date of it and everything. So here I have put in everything that the client might need to attach electronically, and this is it for the schematic part. I then look into the possible ways of organizing my code. So the first thing that I noticed, as I said, was the menu system was a big problem. So the first thing that I did was try to make the menu system as automated as I can, because I remember a few years back when I started with my menu system programming, the code was around 2000 lines long, which was very unnecessary. I then realized later on that I could have saved all that space with linked list and so on with the data structures. But then, of course, learning that is a you know uh, a process as well. And then I learned that, and but here it was there was no need for such a complex menu system. So I decided to keep it simple and implement a few structures and implement you know um, a few switch statements which would simulate the states of the machine, and I'd like to show you how I started with that. Of course, I first made the state of the machine or the menu system. First is the edit stage, the idle stage, the begin, and the press. In the begin stage, of course, it would start the pressing process, and it would ignore everything else. This creates for a very focused kind of a programming where you're not worried about all the other things that is going on, and kind of gives you that very eagle-like focus to see what kind of problems you're facing. And so this is why I went with the state. And of course, this was also needed because I needed no delays in this project, because this needed to be run continuously, and this was a challenge for me to try to implement this with as less of delays as possible, because delays, they halt your CPU, which in turn stops all your code and brings about unnatural kind of delay that is in the thing. And then I created a timer for it. So I understood that there has to be a timer that they have to set for the pneumatic press. So whenever the limit switch gets pressed, the timer would start running. And so I started with another enumeration that would be for the minute, second, and the tenth of the second. Now here's another interesting thing that has happened here. Normally the timers are off for the second, minute, and hours and days, but then here they have decided to go till the 10th of the second, and this was probably one of the reasons that the client came to me, because they could not go into that kind of resolution. So this was another point that got me alert that okay, I'd like to look into this a bit more detail. And then I programmed in. Then I understood that the client would also need the timer to be always remembered and not always put it in. This is a given whenever there is a timer, because how often do you come up and put in the timer again and again? I asked the client, I communicated with him whether he wanted the timer to be frequently editable, and he said I would not like that. This would be just a one or two time thing where I'd like to do that. And of course, in a factory setting, you only do the setting once. So I made sure that the kind of the going into the menu system or activating the menu or the editing section needs to be as hard as possible, because it doesn't need to trigger whenever or with whatever kind of okay. Moving on, here is the some of the symbols that I have tried to implement into the menu system. There's an arrow that would signify that the selection is made, and it would actually blink. This is something that I always like to add in my clients' projects when they have not asked for something, for example, a blinking of the arrow, but it was a nice additive that I wanted to put in there to kind of make it easy for them to kind of know what selection they have made, whether they are changing the minutes, the seconds, or the tenths of the seconds. So, and sometimes they don't appreciate that. Sometimes it is kind of your own programming challenge when you like to implement such new stuff. And I had never done that, but it turned out quite well. Here's another second symbol to be programmed into the LCD. Now note that the LCD has probably around 7 slots for this, so you can assign it, for the 0th slot, one kind of an array, and for the 1 slot, another kind of an array. So all of these objects can be stored inside the registers of the LCD, and then when you call them, it will be easier. So again, I am going to move into, now notice that I have also commented everything very specifically. This is not so much for the client, this is for myself, because I always tend to use my code again and again. But when I look at my code that is 5 or 6 years old, I cannot understand what's going on. And so I would also always like to go back and see my mistakes and what kind of an approach I had taken. So this is why I add all of these comments, and to also share my projects online so that people can benefit from them as much as I have benefited from the work of the community, which I'm very thankful for. And then, of course, there's the countdown matter, which we are going to discuss. But it is also, I wanted to first take a different approach, for which I made this state, which did not work out quite well. So I left it in there just as a reminder to myself that, okay, you tried this, but it did not work. So even in the future, if you're trying to do this, don't do it. And then I always like to add in my project some configurables for the client. Whenever I deliver some kind of a project, I always like to give them that sense of control, that okay, this is a custom project which can be configured and changed according to their needs. And there wasn't much that could be changed in here. There was a blink delay, which was a refresh rate of the there's a blink delay that would control the blink rate of the arrows that are turned on when the selection is made. And then there is a screen refresh delay, which tells you that okay, that your screen needs to be refreshed every 50 milliseconds. If they want a high refresh rate and very high rate of counting, that can be done here. And then timeout delay, which I have made so that when the client enters into the edit mode and they don't make a selection within 60 seconds, they get timed out and the settings do not get saved. So if they forget to commit the changes, the settings do not get saved. So here are the configurables that I have made, and then there are some variables that I'd like to always highlight that these are some kind of initial variables that are not much useful in the stage, but in the code they are useful. Then I'd like to always configure the timers. I always like to make lots of timers to use a non-blocking type of code. And as I said, it is a challenge to me every time I code one of these, that I would not use any kind of delay. But then to make things easier, sometimes you have to do it. And here is where the functions start. And here I have made a update a timer kind of a function, which whenever you are in the update screen, the screen would update every 50 milliseconds and then refresh the display with the new kind of data that is stored inside the structure, which is T, and that is from the timer structure. And I have set exact specific places for the characters to be printed at. This stops it from being sliding slowly to the right, and this provides for a very controlled kind of coding. Then there's a calculate a timer second in seconds function, which when we save the time in terms of minutes and tenths of seconds and seconds, it takes that time, converts that into milliseconds, and then stores it into the variable timer in milliseconds. And then there's another function which updates the state of the buttons. Here I'm using a library for the button which handles the debounce state of the buttons, and it kind of gives me that kind of an abstraction layer where I do not have to worry about even the buttons. So I'd like to use as much libraries as I can in the project, where the crucial stuff is handled by me, but the trivial stuff is taken care of by the libraries, where the repetitive stuff and making a class out of it and everything, that does not need to be done by you every time. So coming up here, of course, then you have to commit to EEPROM when the setting is saved. So I always check whether the flag is high, and when it is, I first set that to low, and then whatever the case may be. And this is why I made the enumeration stage, because it kind of helps you by dynamically deciding what kind of a stage it's in. So instead of putting in the if else statements and the saving mechanism in every kind of the state, you make a single enumeration, and then you let it decide on its own what it's doing. And I'm updating the display as well. Moving on, here's the update arrow function, which is a complementary thing from me. Again, here I'm trying to see if the section is selected. So if they have made a selection of, say, minutes or seconds or something, what happens is that button state gets red. It checks if the timer is there, and then goes into this blinky state, which is probably easy to read, but I will not go into much more detail of it. I will show you how it works, but this is not really the possibly the time to go into that. Then of course, if the selection changes, I update the results and put it on the screen. And then of course there is the menu buttons handler, which handles all of the menu system that is built into this LCD or this project. Always I have to check whether the project is running or not. If it is running, I will not make the changes. If it's not running and everything is safe and secure, I then make the changes and put it into the EEPROM. Of course, here is the mechanism for the up button, down button, and I make sure that whenever the digits change, there's a refresh of the display to clear up the LCD. And this comes with probably with some experience. It's not really programming related as much as it is experience related. And here is for the minute again. Then there is again for the second part and the 10th of the second part. So this was pretty long and interesting. So whenever the mode button is pressed, the commit flag gets high, commit to EEPROM gets called, and section selected turns into false. All of the timers gets reset so that we can do the process all over again. Coming into the setup, I always get the first boot register, which is inside of the EEPROM. I always have one of the register which tells me whether the microcontroller has booted for the first time with my program, or is it the second time or third time. Because if it is the first time, I always clear out the EEPROM and write it all with zeros, so that my EEPROM is a clean slate. And from then on, I get the minute, second from their appropriate registers, and I try to use it. And of course, these methods are very well documented inside of the Arduino's framework if you use it. Again, we are making some initial welcoming messages and trying to initialize the stuff, which is pretty self-explanatory. Then going into the loop, I'd like to always keep the loop as clean as possible and as clutter-free as possible. And I'd like to implement all of the logic inside of the functions and then call them as much as I can. So if you look in here, if I just try to collapse all of these, you see that the whole loop is divided into sections of cases: idle, edit, and begin and press. The boot, whenever it's booted, it's always in the idle state. Goes in there, make sure that the relay and the LEDs are off, and try to see whether the condition for starting the press is fulfilled. If it is, it changes the state and goes into that state instantly. And so I made sure that no other conditions get executed once the state is changed. So this is where that control comes into the code, which is very important. And you try to measure every kind of possibility and test it as much as you can to really not allow any kind of anomalies inside of the project. Going into the edit part, of course, what we're doing is update the timer and menu buttons handler. Here is where all of the menu editing settings is going on, and I have made sure that the menu is not triggered by mistake. So I have tried to measure how long the button has been pressed for. So there has to be a combination of buttons that needs to be pressed for around 1 second for it to trigger the edit mode and go into the idle mode, etc. Then comes the begin mode, where the initial conditions are fulfilled, and then we go into the press mode. Of course, we see all of the criterias and requirements of the client. If the limit switch is not pressed, then keep moving. If it is pressed, then stop. I guess most of the problems that people feel, or the beginners feel, of course, is in the if else statements. So this has to be very carefully crafted. Usually these gets triggered when you're not expecting them to trigger. So a good way to check this and debug this is to add in a few serial commands, which tells you where the code is going on right now. This is the finalized code, so I have not put it here, but I do always put a ton of serial commands to show me where the code is actually going. And then there's the actual press, where the limit switch is activated and the timer gets taken care of. So here I am, of course, checking that the timer is updated and it is decrementing properly. And then I have also, if you see a bit closely, I have added that the display refresh has to be controlled here as well, because that introduces some kind of a delay which is unrequired. And display writes take a lot of time, because it is through I2C, and it's kind of slow. It's not that fast, but I have seen in this case it doesn't really take that much time, so I probably don't have to worry about that. So coming in here, if we have the permission to update the screen, we do it, and we show the timer in terms of seconds instead of milliseconds to make it easier for them. So of course there's always the part in the backend where you do things whatever makes easy, whatever makes it easy for you. And then there's a part where you have to show the client what's going on, and they don't have to go into the technicality. So you have to make that distinction to create a kind of aesthetically pleasing projects. Then going on further, again, I try to take care of the LCD, bookkeeping and stuff. Then once the timer has ended, I make sure that it goes back into the initial state so that we can accept some more inputs. Of course, I'll go in there and show you how it works. This is the best part of this website, possibly. When we go in there and start the simulation, it will do everything online, and of course it's the firmware is loaded. At first we are greeted with this screen: press buttons to activate the press, and the way you toggle the buttons is with command and click. So once this is clicked, as you see, the shadows change. So you push this and then you push this. Now as you see, the relay is on and the light is on as per the requirements, and then the press gets moving up to the closing point until the limit switch is pressed. So there's also in the abort function, where if one of the switches is let go, so because of the safety, the press has to turn off 100%. So if one of this gets turned off, as you see, aborting, and then it goes back into the accepting the command. And then you see, of course, when we press the limit button, it starts the countdown, and it tells us that okay, now we have reached a close position and we're doing the countdown. So I've programmed in the 13-second delay in here, but we can edit that later on. I'll tell you how to do that. So going in here, here's the reset button, which resets your whole controller, and it works precisely as it does with the microcontroller, connected to the reset button and the other to the ground, which helps you do that. Okay, doing the combination up and mode, this should put you in the, wait a second, let's abort this so that we leave this. See, we press the up and mode and we got into the timer. Here is the minute symbol, second and tenth of the second symbol. We let go of this, we navigate with up and down, and here is the 30, and unless the selection is made, it's not going to blink. And let's say we want to change the seconds, we press on mode, and now it keeps blinking. This was a pretty sweet part which I was really proud about. And if you press up, it's 12, 13, 15, 18 seconds, 20 seconds, and second set, a confirmation for the user that it is perfectly working. Coming in here, let's change the tenth of the seconds, which are properly called deciseconds, but our American friends would like to call that tenths of the second. So let's go into the mode and I save that as well. Now to exit this, you have to press on the down and mode button, which takes you out of the thing and commits the changes and everything into the EEPROM. Going again into the project, pressing the initial conditions. Of course, now you keep the buttons pressed and you push the limit switch. Now the timer has changed, right? Even if you let go of the buttons, it's not going to abandon the thing. So it's going to do the countdown and then return to its original position, where it's going to accept the new commands for the press to begin. So this was a pretty interesting project that got me the idea of sharing with you how I'd like to take things. And and I always like to share my projects, and even this project I would definitely, I will be sharing it on the GitHub and sharing the link to it. But I hope this was helpful, and very glad that this website exists, which is so good for the microcontroller development. And this is just a small use case. I would love to integrate that into VS Code, which they have the support for. It's not a sponsored video, by the way, but yeah, I hope you enjoyed this, and thank you for watching.